Welcome to lesson 1.6, Graphing Relations. The focus of this lesson is to create a table of values, which we've done in previous lessons with your input-output tables. And then you're going to learn how to graph that data. I'm going to try to keep this one short and sweet, and simply there's 5 steps that you need to follow when you are graphing your data in your table of values. So I've listed those things right here on the first sheet. So to graph a relation, you need to follow these steps. So you need to create a table of values, and we'll look at an example of that in just a moment. Number 2, you need to choose scales for horizontal and vertical axes. So your horizontal axes is your left to right line in your graph, and your vertical axes is your up and down line in your graph. And again, I'll show you an example of what that means in just a moment. You need to use a ruler to draw your axes so you have nice straight lines on grid paper, and you need to use numbers to indicate your scale on both your x and y axes. You need to label your axes and give your graph a title always so we know what data we're looking at and what your graph represents. And then you need to plot your data in the table. So I've pulled an example from our textbook. I'm on page 32 to really highlight for us these 5 steps that you need to take to graph a relation. I didn't really think it was necessary to go over how to create a table of values because we've done that in previous lessons with our input-output tables. So I've just pulled these ones straight from the textbook. So our relation here is that n is related to 25 minus 3n. We have our inputs here, so 0, 1, 2, 3, 4, 5. And then we have our outputs, 25, 22, 19, 16, 13, and 10. So once we have that data in our table of values, you've done step number 1, to graphing your relation. So we've created our table of values, which is right here. The second step, we need to choose scales for our horizontal and our vertical axes. So what I meant, our horizontal axis is this line down here on our graph, and our vertical is our straight up and down axes. That's just the name that we give for those 2 lines on the graph. And a scale means the numbers that either increase or decrease on our both of our axes. The scale for your x and your y axes do not need to be the same, however they need to be consistent. And what I mean by that is if I'm going up by increments of 1, for like this one is an example, 1, 2, 3, 4, 5, I couldn't all of a sudden halfway through my x-axis start going up by 10s because I realized that I have a much bigger number and start going 10, 20, 30. Whatever your scale is for your x and your y-axis, it needs to be consistent. So our scale for our x-axis here is 1, it's increasing by 1, and our scale for our y-axis in this example is 2 because it's going up 2, 4, 6, 8, 10, and so on. So your scales need to be consistent, yet not the same for your x and your y-axes. So that's step number 2. Number 3, use a ruler to draw the axes on grid paper. So as you can see, this example is using grid paper. Please use a ruler just to keep things neat and organized and not to maybe misinterpret what your data is saying if it's kind of messy or hard to read. And use numbers to indicate your scale. So just like we've kind of already pointed out, the numbers are shown on both our x and our y axes. You need to label your axes. If let's say you didn't have your labels here, I wouldn't know what those numbers mean or what they represent. So you need to have a label for both your x and your y axes to let me know what those numbers mean, what it is you're graphing, and what data you're trying to represent to me. And you also need to give your graph a title. So what is your whole graph representing? So this graph here is looking at granola bars that are left over. We have our number of helpers, and we have the number of granola bars left. Like I said, there was a word problem on page 31/32 to go with this table values and this graph. So if you want to read that question to get a better sense of how maybe they came up with these titles, then please feel free to do that. And then the last one, plot the data on your table. So how you would do that is if I'm looking at 0, for the number of helpers, so I'm going on my x-axis because that's represented number of helpers, I find 0. And then my input is 25, so where my x is 0, my y-axis goes all the way up to 25. So this column will be your x-axis, more likely than not, and this column, more likely than not, will be your y-axis. So, just continuing on, just to see how they've plotted their data. When my number of helpers is 1, my number of granola bars left over is, 22. So that's how they've plotted that second point there. When their number of helpers is 2, their granola bars left over is 19. So you can see where they've plotted their third. When their number of helpers is 3, the granola bars left over are 16, and so on and so on. So they've just went through their data table, followed along their x-axis for their numbers of helpers, and then found their y-axis for number of granola bars left over. So for this lesson, it's just really important to remember that you need to include those 5 steps to graph a relation. And then just the last thing I want to point out is the term linear relation. When points on a graph, or if you were to place a ruler over those points and they make a straight line, which these ones do, for example, we call that a linear relation. So those are the main points of how to graph a relation. Please make sure to keep it organized, use graph paper, use rulers, label your axis. That's really important. That's really important to display your data and let your reader know what it is that you're showing them.